so if I look up, so here's the drag formula, and you need a drag coefficient, so, and then if you look up drag coefficient, I don't know if I spelled that correct, formula, then if you look at this, you need the drag force, which is actually derived from, you get the drag from the coefficient, but to get the coefficient you need the drag. So you need to do testing. So I'm just gonna do this. I'm just gonna just fake it, I guess. Oh, and also I'm posting this on GitHub. So if you go to github.com/openchanter, so I've posted a few things here, I guess. If you want to look at the previous Pygame Physics thing I made a little math library that's public. I made a web chat, which I actually put on a website that I'm just, I guess I'm just gonna, let people at my school use it. So, yeah, that's about it with my GitHub. So yeah, it's Python Fizz 2.0. It's coded fully in Python, so if you know Python, you can modify it. Okay, so now I need to come up with this. Wait, divided by? No. Can't be divided by. Oh, divided by self.density times 10. I think this should work, so it's probably not gonna work. Oh, now they're upside down. Oh, that's not good. Divided by self.density times 10, so alright, if we just change that to an addition, then the problem with that is the one on the right has more mass, as you can see by that. Maybe if I just, for the drag formula, change this to multiplication. Yeah, that might work. Yeah, there we go. So now we have the two objects moving, but the problem with this now is if we set this to 0.01. Actually, so here's a cool fact. Did my headset just turn off? Let me just check. Nope, my headset did not turn off. I thought my headset turned off. It made a noise. My PC made a noise. Oh, that's my mouse I'm charging. Okay. I was getting really confused there. I'm getting Discord messages from this guy. Oh, okay. He's watching my stream. How make my mic louder? Let's see. Properties. There does not, wait, maybe I can set this to like 200. Can we do that? Oh, I've just made myself quieter. It will not let me set that to 200. I guess I'm just gonna have to talk louder then. I guess just say in chat if this is better. Just type in chat, tell me if this is better, I guess. Um, I guess I just need to talk louder. So, yeah, tell me in chat if this is better. I'm gonna go back to my code. So, okay, actually here's a fun fact. So the density of air is actually look, if you look up the density of air in pounds per cubic foot, you'll get 0.7967. Still quiet. Okay, I guess I need to basically yell into my mic. Or maybe you just have your I mean, I don't mean to be like, what is like, I don't know what the word is. Passive aggressive. Maybe you just have your volume low. Yeah, but 0.7967. So with what I've just come up with here, if you if it's below 0.8, I mean, why does that one? Why is that one S? So 0.7. So that will actually still it'll still just fall slowly. So it's about 0.8 pounds per pounds per pounds per cubic foot off, or 0.7 pounds per cubic foot off. Sorry, because if you put it at that, cancel. Then you have that. It's snapping to the ground for some reason, which is confusing. Um, so actually, if I just make a readout for that, and I guess the FPS, and then so if I just make this print self dot drag, okay, so now if we on our object 2 we'll do true. Oh, by the way, so I've set this up so Y0 is actually at the bottom of the screen, so if you want to use that, that's a good thing for me to tell you. And then uh, actually, if I get my thing here, find this there, that's it. CurseForge. Oh god, that's not good. Okay, so I hope I didn't mess anything up. So if I run this, right, and it loads, and I select a pencil, and I actually turn my pen on. There we go. So right down here about, that's the origin of this. So like, you know, if you have anything more than a, okay, so look, middle school level of understanding. So this would be x0, and then this line down here would be y0. So, like right about here, we have our origin. I'm not very good at using this drawing tablet, but so yeah, that's how that would work. If you want to use this, let me just get my eraser and erase this. And now I'm going to use my mouse again. So that's how that works. But the problem that I'm facing now is I don't know how that's not outputting often enough. So, self.fps. I'm just gonna make something for show drag equals boolean bool. Why can't I type right now? So I'll make a boolean right there, and I'll just do if so not self show drag then print self.drag. Okay, so now if I do false, 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 true, false, true, then I can, yeah, that should work. So now we'll be able to see, but I think, so I think that that's a problem with this. So it checks if the position is below 0 plus self.scale divided by 2, which would be the origin of the or the center of the cube. Sorry, not origin. Then it'll snap it to there. And and I'm using syntax for C# for some reason. I don't. And self dot velocity, or the absolute of self dot velocity 1, which is our y. Oh, why is this? My cable is not working for my mouse. Okay, there. Is more than 0, or the 0.01, I guess, would be a good number. So now let's see if it still snaps. It still snaps. It looks like, actually, we don't want to show the drag. Velocity, I'm just going to leave it as show drag because this is temporary. So maybe, wait, let's see, how many frames does that happen over? So if we look at this object, it still seems to snap. And I don't know why that is. So if we scroll up through this, actually, wait, let's stop the execution of this program. See if this gets up to anything. Nope, it appears to not. So I don't know what's going on here, but yeah, I guess. uh, yeah, that's gonna be maybe a bit of a problem later. Let's see. Okay, I understand all of this completely. Yeah, of course you do. Why is it under the category people and blogs? Am I able to change that? Oh, it's probably under here. Playlists. Category, there it is. Okay. I probably should have changed that a while ago. Science and technology. That's a very good category. Other YouTube stuff, blah, blah, blah. Now we can go back to coding. The next thing that I wanted to get working is circles, because if actually I'm gonna remove this, and we will just put this at the origin halfway up the screen, because as you can see here, the screen is 500 by 500, and if we just put in this here, I actually removed that second thing, so now, but if we make this a circle, there's something broken with it. I think it might be the rendering. Oh, no, it worked. That's a very big circle. So we're going to need for the circle renderer, we're going to need self-deposition 0 plus 250. And then for the scale, we're going to need self.scale divided by 2, because for the scaling of a cube, you have, for this it's the x and y, so the scale is just 50 by 50. But for a circle, if the radius is 50, that circle will actually extend like twice, I guess, further than the edges of that cube. So, yeah, so that's why we have to divide it by 2. Now let's see if this works. So now we have our circle, and it falls. Very good. And I think maybe, okay, I need to add a collision for the top of it, right? Yeah. Oh, there are no more concurrent view. Wait, what? The hell? Those are different. Okay. Um, okay, so I'm just gonna, what is it? I need to, for this, I need, so there's this right here, which calculates the drag. So then we need another else if statement, and we're going to set this one to the same thing, but it's going to be position is more than 500 plus self.scale divided by 2, or minus self.scale divided by 2, because this is the top. So now we can actually just do the exact same thing, but adapt this little code that I've already written. 500 minus self.scale divided by 2, and I meant to hit the up arrow. So now that works, and if we set it to something lower than that, 0.01, I think, should be a good number. It should float up. It doesn't float up. Why doesn't it float up? Yee! Okay, let's make it an even smaller number. This is getting less and less accurate by the nanosecond. Wait, does that just not work for circles? Wait, square. 0.01 and what? Wait, so if we have our self.g times self.density times 10, so we actually need it's that. So then, I mean, I know the order of operations doesn't matter, but we have self.density times 10, so then we would have 1, and then that's oh wait, no, this needs to be minus drag, and then this needs to be negative self.g. Wait, wait, no, so if it's, wait, so we want anything below 0.1, and I don't know, a mass of 1 pound per cubic, no, square foot, 1 pound per square foot. Anything less than that, so we need, if it is less than that, so we have density times 10, meaning 0.1, a density of 0.1 will cause it to, or density of 0.1 will cause it to flow. So I guess the density of the air would then be, sorry, 0.1 pounds per cubic foot, and yeah, that sounds right. So we need to subtract self.g times, and then if it's times 1, then it'll stay in the same spot. I think this should work. So, wait, self.g. No, negative, wait, no, plus? Wait, I'm trying to figure this out right now. Is there like something? So, then it falls. Yes, that is very good. No, it isn't. That's very not good. So no, we need to subtract it, right? Because then it can't accelerate at 0.1. So what I'm hoping to see, unless I made a mistake, perfect. That's exactly what I wanted to see. So now 0.01 should make it accelerate upwards, right? No, nope. Doesn't do that. It doesn't work like that. But why? But why? I don't know. Wait, what about 1? There we go. Okay. Figured it out, I think. We have to switch that to division, right? Will that work? So 1 should make it fall, right? Nope, that's not right. 1 will make it fall. Am I correct? Oh, lag. It lag. No, you shouldn't lag this time. Good, it falls. That's very good. So now if we make it 0.1, it'll stay perfectly in the center of the screen. Perfect. Now if we make it 0.01, once it, oh, there we go. Oh god, that's, I have a sore throat. There. And now if we set our density to 50, let's try this. We should shoot to the bottom of the screen. No. No. No, no. Are we just reaching some terminal velocity? Okay, wait, let's do some comparisons. Negative negative 100, and then we have another one, which is going to be 1, and it's going to be at 100, and then we do phys_obj dot frame false, but we're going to just name that one 2, phys_obj2, and then they're falling at very slightly different rates, which I think is good. I mean, like, now what if we compare 100 to 1? So you would expect this to fall at 100 times the speed, but it doesn't. It just falls a bit faster. But maybe that's 100 times the speed. Maybe that's like 100 more pixels. I don't know. It probably. Oh yeah, when you increase the mass or the density, which is this, to 100, it'll actually fall at 100. So um, when you increase the density, so at 1, it falls. So at a density of 1, it falls at 1 pixel per second, right? But then at 100, or it accelerates. Then so when your density is 1, it falls at, and then density 100. So at density 1, it would um it would accelerate at 1 pixel per second, and then at density 100, it accelerates at 100 pixels per second. Who messaged me on Discord? It's still quiet. Well, that's great. That I'm not gonna respond to that yet. So this is, fuck. Sorry for the profuse swearing. That's why I made this not for kids, because we don't want this on YouTube Kids. Uh, and 100. So what it's calculating right now is for the one on the left for phys underscore obj, um we're accelerating. Wait, no, that's not right. That's not right. Because so we're accelerating at g, right? G squared. But for our purposes, I'm just calling it g in the program. So they're both accelerating at g squared, but because of the higher mass, because 100, is more than 1, um, phys object, this one, falls faster. Because it's receiving less of our fictional drag because it has a higher density. So if we change this to say 1000, it's still only falling very slightly faster. What about 10,000? Yeah, it doesn't seem to make a difference. Wait, oh no, this wouldn't be very good. So I'm just gonna do phys_obj, phys_obj1, and then so we have 100 to 1. Now we need to do phys_obj 1.frame false. I have to fix this so these two. Okay, good. Oh, I was worried there for a second. So the reason that this is happening is we just have such a minuscule amount of area for this to fall. Wait, it looks like, oh, the one at 50 is actually falling slightly faster. I don't know if that'll actually happen in real life. Usually heavier objects will fall faster. Anyway, this is a simulation. Again, if you want to try it out, just go to my GitHub. I'll put that in the description, actually. So I'll edit this. Wait, who's actually watching this stream right now? Just type in chat. GitHub. https github.com/github.com/openchanter. There's my GitHub in the description. Who would be the concurrent viewer? See it on my concurrent viewers graph. Please tell me if you're the concurrent viewer. I'd like to know who that is. Okay. So that works. Well, let's see here. Well, let's actually have two objects of the same mass. So we'll actually delete phys_obj1. We'll make them both the same mass, but we'll make the one on the left a circle. Very, very, very simple. As you can see here. Now, they fall at the same rate, because apparently those two have the same mass. I don't know. I'm not a physicist, or am I? But, oh, I just thought, I just did the thinky think. I just did the rinky dink thinky think. This should be divided by 2. I don't know why I called it rinky dink thinky think. That was stupid. Anyway. Oh yeah, it's the same. I divided it by 2 and squared it, but it's this. Wait, am I being stupid? Wait, so 4 divided by 2 squared is 4, right? 10 divided by 2 squared is 25. Oh, you wanna know why? Because 1 divided by 2. No, it isn't. Wait. That should have a lower mass. Huh? Wait, can I? Where's the. Oh. Let's see here. So. Print self.mass. Let's see here. What are we gonna get? 2500. Which one is being executed second? Which is square, so the square is more dense, but it's just so minuscule it doesn't really make a difference in how fast they fall when you have a 500-foot drop. So, wait, how long have I been streaming for? I just want to know that. That's not how long I've been streaming for. That would be in Streamlabs, wouldn't it? I don't know how long the stream has been going on for. Wait, I can just go. About 30 minutes, including that. Okay, well, what the? Kind of hope this makes me more views when I edit it. So today I fixed the physics. I made circles work. You can look at this at https:// You don't have to enter the https. You can look at this script at https://github.com/openchanter. Yeah, just like Python physics, Python Phys 2.0 or something. I think that's what I called it. So yeah, if you want to try this out, it has the main.py, the physics.py. I'm actually going to commit. I'll just call this fixed drag and circles. I'm going to call this artificial drag and circles. So, there. Okay, so now I'm just going to sync these changes so you can download this if you want. It has some information. I put it, actually, I'm gonna edit this real quick, readme.md, because I'll put the example script just in case, like, you modify this, you don't have to re-download it, I'll just put it right here. There. Updated readme. Commit, sync. Okay, I think that's gonna be the end of the stream for today. Yeah, so in conclusion, we fixed the fix a drag, and circles now work. So you can download this at github.com/openchanter. And you can download my other projects if you want to like host a web chat. I mean, like you can change the backgrounds if you know a bit about Python, not Python, HTML. I mean, you barely have to know anything about HTML anyway. But yeah, host that if you want. Use this for whatever projects you want. If you know a bit about Python, I would love to see a game made with this. Like, comment somewhere on my channel with it. If you make a game, that would be amazing. If someone watches this and makes a game with my engine, I'd be amazed. That'd be cool. Yeah, so that's gonna be the end of the stream. Thanks for watching, everyone that watched, and I'm gonna post this as a VOD, so I think that's what it's called, but I'm gonna post this as a video on YouTube, so that's gonna be the end of the stream. Thanks for watching, bye.